a good sign. All right, we're getting the thumbs up. Thank you everyone for your patience. Good morning and welcome. We are presenting the creative solutions to preserve your investment and address maintenance and construction deficiencies in housing in the Three Sisters room. So hopefully you found yourself in the right place. And basically what we're trying to address in this presentation is Inspections Unlimited does capital needs assessments, and then we hand those over to Pence Construction, and they work with it on the construction side of the project. And so in reaching out to some of our clients and asking them what they'd like to learn about at the conference, we found, budgets and funding is obviously limited. We want to preserve these structures either, from day one when we're on the design side, or in rehabs or just repairs over time. Where should we put our efforts? And so as our inspection company, when we do capital needs assessments, we actually see a lot of themes of things that happen throughout properties that, there are some ways we could try to avoid them with architectural solutions and different strategies. So hopefully you'll walk away with some new information and then also just some good reminders on best practices. So we have the three of us up here. We'll each give our introduction. I'm Jessica Schultens. I'm an architect licensed in Oregon and more recently Washington. I grew up here in Oregon and went to the University of Oregon. Got a Bachelor of Architecture degree there and then started working on the design side. And so I've worked on a variety of different styles of projects, everything from residential to multifamily housing to commercial, new construction, rehabs, seismic upgrades and renovations, and then transitioned to later in my career of working more on the inspection side. So that's a little bit about my background. And let Dan introduce himself.
I'm Dan Lubers. I come from a maintenance background, actually. My chosen career was youth camp conference center management. Somehow that drugged me into being an inspector, and probably about 30 years ago, being in Salem and running around the Capitol, Frank Silke decided that he needed help and worked with Frank on stuff. And I became a multifamily guy and helped the state with troubled properties. Went across the 11 Western states doing syndicator audits on tax credit properties, and ended up now being the old guy on the block that's bringing some of the past back around and alive and keeping some of that knowledge around for the younger generations that are working hard to get us good, affordable housing that has a good lifespan and at a reasonable cost, hopefully.
Always. Dan, thank you for referring to me as a younger generation. I appreciate that. My name is Philip Johnson. I'm with Pence Contractors. I've been with Pence for 20 years, essentially my entire career. So classic, U of O, Oregon State, CEM, that dichotomy. Yet we still got a slideshow put together. It's amazing. But yeah, been with Pence my entire career. Started as an intern and been lucky to find a place I call home. We're a full service general contractor, playing in many different arenas. Multifamily makes up probably 30 to 40% of what we do in our volume. Other portions being K through 12 and higher ed, and then civic and government office buildings, things of that nature, retail, rec. But well diversified portfolio. I've had the pleasure of working on many projects that Inspections Unlimited has come in at the front end and produced those CNAs, sat down with clients then after and worked through budgets, worked through funding rounds once, twice, maybe 3 times, but then have the pleasure of going through that. So it was a great synergy between what they do coming in early to look at the properties and then us come in later and how we then interpret that CNA working with the architects to create a plan that can be put into place. And I think one interesting thing Jessica talked about, you're going to see a lot of stuff in this slideshow about rehab and preservation. And please note these lessons learned are not just for a rehab or preservation project, but when you're approaching a new build. What do you do to set it up? Because you want that property to be viable, providing homes for individuals for a long time to come. How do you put yourself in a position where that CNA can be focused on critical aspects and not some nuisance things that can be avoided with some forethought?
All right, so up on the screen is the agenda. As we move through, we've basically categorized things into bigger themes, but as you can see, we're gonna cover things from landscape to more actual systems like air conditioning and so forth. And so our first category is landscaping, creating separation. And so as we move through these slides, I'd actually prefer for it to be more interactive. And so the first slide will be some images. And then if there's anybody in the room that has an idea of, you know, what do you think that we're trying to communicate in this that's a possible deficiency or something that needs to be corrected? Before we dig into that, I'd actually like to get a sense of who is in the room. By a raise of hands, if there's anybody who's kind of managing properties on sort of development and that sort of thing. So we have a few of those. Are there any other architects in the room? Got a few. Anyone with construction or maintenance background? Great. Anybody that wants to say who they are that I didn't say their category? Okay. All right, so let's dig in. So as far as landscaping, if you want to raise your hand and kind of volunteer an idea, yeah? Yep. Can you guys tell what's happening on the image on the left there? Yeah. Yeah, and so on that particular image, what's something that's interesting in newer construction, on your building envelope, we're starting to have an air gap and a drainage plane. And so what I'm finding is if the landscaping is not contained or far enough from the structure, it's actually, and especially if it's more vine-like, it's having the ability to seek out that moisture. And so that one was growing up from by the foundation all the way up the siding and coming out the trim. And so then the image that is on the right side, you know, this is pretty common. I feel like even some of us are probably guilty of this at our homes, where over time you want to replenish, you know, your topsoil, your bark dust. And so what's happening is you're adding it layer by layer. And so there's some wood trim down there and the dirt is piled up against it. And as we all know, we actually want to create a separation. You know, 6 to 8 inches is where you actually want to be. And so there's moisture that can wick up into that siding and, you know, start to create dry rot. But the other thing is you're also providing a pathway for bugs, and so wood destroying organisms. So then if we go to the next slide, some ideas, you know, your baseline is, okay, let's pick plants that are not going to be vine-like, keep them, you know, 3 feet away from the building, you know, create a large separation, know what they're going to get to when they're full size, and maybe try to lean towards something that's more like wild grasses or things that are going to stay a little more compact. So those are some of kind of the design side. The most cost effective of just creating that separation and being mindful about what you're planning in the first place. However, if you want to take it a step further, some things that I've seen is actually using rocks as a border. And so you can pick ones that actually drain well. So it'll also help moisture to get down if you have a footing drain. That can help get moisture away from your foundations. I know some people might be concerned with the throwing of rocks or providing something that gives people the ability to do that. So maybe you err on something that, you know, of the smaller scale on those. Another thing is the drawing on the right. I don't know if everyone's familiar with architectural drawings, but what it is looking at is a section detail through the foundation. And on this project, what we've done is on the right side, there's a concrete mow strip. And so it's about 12 inches wide. And so in areas where you might be right adjacent to lawn, and sometimes we'll see in the high traffic areas, the siding at the bottom's getting damaged just from a lawnmower, you can actually create a physical separation, a physical barrier that sets the landscaping off of the building. So that's going to cost a little bit more money on the front end, but then if you're not having to follow up and constantly replace trim over time, I think you're going to capture those savings. And again, if you can't do it around the whole structure because of funding, maybe you just put it in the areas where it's going to be the most helpful and prevent damage.
Hold your contractors responsible too when they try to value engineer that. I know I've looked at those before and said, hey, we can save some money, we got to make the budget work, but it's really important to be thinking about long-term viability. And these are the type of things that seem innocent and easy to pull out, but then, you know, it's impacting you 10, 20, 30 years later.
It's landscaping is very complicated. You may think it's just pretty and simple, but it is pretty complicated because you've got to deal with standards that, you know, walkways can't be near bedroom windows. There's, you know, safety issues with your landscaping. You know, you can't have big bushes for people to hide in. And you got to use some generalizations or keep it general. I know a developer that when he rehabbed all the properties, he removed all the trees, all the landscaping, and he mowed against his buildings. And they were pretty damaged. You know, so being able to create a landscaping that is meets all of those needs is as hard as it is to get a good community in a building.
So here we have a photo of some deficiencies. Anybody care to take a guess at what they're seeing on the left-hand side? Go for it. All right, I love it. Yeah, exactly. You have a tree that has been planted. They're beautiful. We love trees. We're all Oregonians, maybe some Washingtonians in here, but we love our trees, and they create vibrant communities. What do you see in the right-hand photo? Go for it. Somebody. Yeah. Yep. So oftentimes you may put an evergreen in and you think, well, that's not going to drop its leaves. Well, they drop their needles and they blow. So here we will, the solutions here that we like to see is proximity. So trees grow, they get bigger, right? Keeping it away from hardscapes. And people are typically pretty good about thinking about hardscapes, sidewalks, and keeping the trees away, but oftentimes the structures themselves too get forgotten about. Where's the predominant wind coming from? Keeping it away from the buildings. You know, maintenance is always one of those things you try to strive for, that zero maintenance building, and that doesn't exist. And so the other thing we can also implement is root barriers, and we recommend you do that always. If you're ever near a hardscape or structures, get root barriers in. That forces the roots down as opposed to out. It actually makes it for a healthier tree anyway too. It's gonna be more drought resistant, but it's gonna keep those roots from going over to the sidewalk panels. Once you start to have those sidewalk panels be impacted, there's really not much you can do. You're going to get an arborist out. You're going to cut some roots if they allow you to. You're going to be now into jurisdictional issues, as trees are very sensitive in our region. And so it's going to be something that is going to be an ongoing maintenance issue. So the best defense is to really be thoughtful about where you place that tree and be implementing root barriers when you originally plant those trees.
And March, maintain the water. The roots go to the water. If you're watering the other side of it, the roots will follow it.
They do have better irrigation systems now that will integrate water down to the bottom of the root ball, which is something that's really nice that they've been putting into projects now. Envelopes.
All right. This one's probably on the trickier side to identify what I'm after. Does anybody have any ideas? Okay. Oh, yeah. So this one could have improved ventilation. So yeah, that's a good thought. Yeah. It might be as well. So on this one, what I'm actually after is you can kind of see the rake of the overhang is pretty minimal. So if you go to the next slide, as an architect and in our climate, what I am always advocating for is a larger hat on your building, because your roof is basically your first line of defense against the weather. So extending those rakes and eaves 2 feet 6 inches, 3 feet, getting them out there so that drip line, if those gutters start overflowing because they're plugged, or just wherever the water is coming down, if we can get that away from the building. It's especially noticeable if you see a single story structure that has big eaves, and then the windows, they end up tucked up high under it. So you're really minimizing the chance, because openings are where we see a lot of the water intrusion and where moisture is actually getting into the sheathing and damaging behind the siding. So I would advocate, even in a rehab, if you have a building that doesn't have very good eaves and it's in a really wet climate, there are ways that you can, during the rehab, extend those, and it might be worth your investment when you're, replacing that roof to look into that. The other thing that you will see in these drawings is the ventilation comment, that making sure that you're bringing it in low and continuously, and that it's going out high as well. We see a lot where it's just a spot ventilation, and we'll talk about that more further in the presentation.
You still in my slide?
I am. No. But it's such a good graphic.
Yes, question.
Yeah, so rake is the image on the right. So that's where you basically have the end of, so the one on the left is the eave, and it's just an architectural term. So when it's on the end of the building and sticking out, that is the rake. Did I explain that well enough?
And you'll have
So I'm going to use my screen. So this is the eave, this one right here. And so on a typical gable, that's kind of on the side. And then when you get to the end of the building, this is so it's just a different orientation of the gable, the part that is the triangle that extends out past the base of the building. So just making sure that those overhangs are on all 4 sides. Oh, sorry. Okay.
And I also want to comment that if you have a building without an eave, your envelope is in a significantly different environment than one that has an eave. Just a 4-inch eave builds a pressure zone against your siding and stuff when the wind blows, so that the rain starts to not push on it and flow in very weird ways. So eaves are really important, even if they're just small.
Indeed. So we gave you a hard one, or obscure. I think everybody in the room would be able to tell what we don't like here. Anybody? Yes. pesky comms contractors. So you get done building a beautiful building, you VE'd out coax to the units, you VE'd all that stuff out, and guess what? People need entertainment, they need TV, and they start posting satellite dishes all over your building, and many different comms come in. We don't like penetrations, right? We work hard on window penetrations and door penetrations and all types of penetrations, and then somebody comes in and puts hundreds of small penetrations and says, "Don't worry, I put silicon on it." Well, that creates issues, and water will find a way in. What we often try to recommend is, one, don't allow skylights, or not skylights, but satellites. But if you do, get them posted off the building. Don't penetrate your envelope. That is your first line of defense. You don't want to be penetrating your envelope. And then also there's specialty pieces that can be used on your roof that integrate into your roofing system that are going to minimize that. But I know if there's anybody in the room from a maintenance perspective on maintaining these facilities, this is probably one of your biggest ires. I couldn't find a photo of it, but we did have a project that we worked on, Inspections Unlimited, did the original CNA, we did the project, and the buildings were riddled with tons of these elements. And we found a pretty easy solution was our eaves were open. And so we raised and relocated all of the comms lines up into the eave and then put soffitting up there. So it raised it all up into the eaves, it's out of the weather, and then covered it up so that any penetrations were attaching it were going to be protected against the elements, and we're able to soffit that pretty effectively.
So yeah, the common theme on that one is basically just have a plan for those things. Know that it's going to be something that's probably going to come up on your property. And so what is that property's strategy going to be as those get added over time if they aren't integrated into the units? All right, this one, is anybody able to tell what is happening here where this mini split system is being attached to the exterior wall? Bingo. So yeah, so this one again, and I think part of what's happening here is it's that exterior envelope, the way we're building walls now, we're adding that air gap. So on this facade, what we figured out kind of from looking below was that there was a gap in that wall, and they assumed that they could just bolt straight through into something solid, some sheathing, but they just damaged the siding. So the siding's warping. You can kind of see that on the image to the right, and then on the image to the left, yeah, if you see the end, you see there's a pretty big gap at where the siding's coming through. So if you go to the next image, if you're taking a section through, basically at a minimum, you need to be installing some sort of blocking or backing. And then you need to also be adding additional protections above. So flashings that are directing the water from your wall assembly out. And then, some sort of siding or protection in front of the blocking. So one of my recommendations is you might be getting funding for something like installing mini splits on your property. And I don't know if sometimes, you might just have a company come in and you don't have a general contractor or an architect on board and they're like, yeah, we can do it. What you really need to make sure you understand is how your building system, your envelope works. And it may cost a little bit more to get some expert advice on the front end. But it's going to save you potentially in the long run from someone who they weren't aware that this was the way that the building was put together. And on that particular property, different elevations had been replaced over time. So it wasn't consistent on every building. There was actually, so some of the buildings were better off. And so anyway, having someone come in that kind of understands, again, how to keep moisture out and can help you through that process is what I would recommend.
I want to ask a question. So I know in the past, Oregon Housing has managed a lot of the energy funding, and there's been some issues with the local energy trust And that's probably what happened here, is that the county came in and added these systems in for the tenants outside of Oregon Housing. And so it got disconnected from that. Who's really doing the energy money now? Is it coming from Oregon Housing? Yeah. So it's still kind of an open game, and you guys are kind of fed to the wolves on whether the person is actually familiar with the housing side.
All right, so more deficiencies. Probably be pretty easy judging off what we saw on the previous slides, but anybody have ideas here? Just more of the same, penetrations, right? So you have things that seem simple and innocuous, fire extinguisher cabinets, you're coming back, the project's over, you're going about, or you get an inspection, they say, hey, we need to add some fire extinguishers, let's get this put in. But it's penetrations, and we don't like penetrations. So again, if you can find alternative solutions where you can not put it on the building, that's always great. Or if you are going to be mounting to your building, be thoughtful, recess it in, have the blocking. Also, get it under cover. If you have breezeways or areas under cover that aren't going to be impacted by weather, you're going to be setting yourself up for much more success for the long term.
And then, well, real quick, the image on the right is actually a hose bib detail with more of, the more common envelope. Now we're starting to put rigid insulation on the outside, so there's more of a thickness there. And so being thoughtful about adding some trim and some flashings and making sure, again, that the moisture that's coming down the wall is getting moved to the outside, and, not just swapping out that hose bib and relying on sealant. Yeah.
This one?
Piece of this one.
All right. Sorry. Whether that's okay, or if there's any issues with doing it that way. As long as you're putting it together properly with, it depends a little bit on the window system, but you're probably doing vinyl, and it probably has the nail flange. Actually, this is a good point to bring up. A lot of times people will, in a rehab, just cut off that nail flange and then screw in through the jambs, which is a no-no, and will create moisture issues. But if you're able to remove the siding and put it in properly and have your flexible flashings and then your other flashings above, you don't necessarily have to wrap it in trim. You can still be successful. I did see a property recently where they had some pretty robust trim above, and even kind of projected out, and it's, again, directing water out and away, and so it's performing better. So I do think that trim can be helpful, but it's not required.
Mm-hmm. Right. Yeah, no, that's a good point. And again, as long as, so it's about where the water's coming from in the system above and making sure that your flashings are going back far enough that everything, it's like bird feathers, that they're overlapping and that the water's all getting pushed out. And so there's different ways you can put it together. And I don't know if I'd say that necessarily having it on the outside or inside is, if that makes a huge difference, as long as you understand how the parts and pieces are going together and everything's directing the water out.
Yeah, and I would say in setting is great, but just the way that we build structures these days, you're going to be using that nail flange window. It's going to be on that face. It's just you're not going to have the opportunity to inset it. Trim, as Jessica said, yes, you don't have to have it. I would advocate for it. It gives you flexibility in the future. If you need to get into that window system, you're not getting into your siding panels now. You're pulling out your trim. You're able to get into that window, remove that system, put it back together rather easily, as opposed to then getting into your siding and where does that go and how does that continue to play out. So is it absolutely necessary? No. Would I advocate for it? Yes. I think it gives you enough. It gives you flexibility in the future, and it is going to perform a little bit better over time. But it's definitely not necessary.
Good question. All right. This one, oh, wait.
Yep.
Thank you. Okay. Anybody have any ideas on this one?
Water is not directed away from the building.
Correct. Yeah, so that connection from your downspouts into your gutter drainage system. And I want to say on almost every single property I walk, it seems like there's at least one location where it's crunched or missing or damaged in some way. And so one of the details that I like is on the next page. And what you can do is you can just make that connection at the bottom of the wall more robust with a PVC pipe or a cast iron pipe, and bring it up a foot. I like 3 feet vertically, but depending again on the situation, if it's in a higher traffic area where it's more prone to damage, if you need to prioritize your funds, put them in those locations. The image on the right is actually from a local school in our neighborhood, and that thing is all the way up and it is never going to get damaged. It is stout. So you may not have the funds on the front end to go to that full extent, and it may not be justified based on the location. But there are ways to, again, on the front end or during a rehab, just make that connection that's more prone to damage a little bit more robust. And then you don't have to worry about constantly repairing it over time. And sometimes when they're repaired, we actually have seen them installed backwards. And so the water's, not being directed in, it's coming out. So it just sort of takes all that out of the picture.
And in doing syndicator audits, I'll tell you that if you go and fix those downspouts and do that, it can make a property really look a lot better. I mean, I visualize a property on the coast that they finally broke down and changed out all their stuff to PVC. They thought it was going to be ugly. The board was very reluctant, but it straightened everything up and just made it look nice, and it was real helpful.
Okay, any guesses on what we're seeing here? So we run into this quite a bit. It's degradation of materials, and you can see the in the photo on the right. It's a modern, well, not terribly modern, but a newer vinyl nail flange window. But I don't see any flexible flashings. Now, of course, the building paper was taken away, but you look around that opening, it wasn't flashed properly. On the left-hand side is again a project that we worked on together. And this is where you get into innovative solutions. You can see where there was degradation of materials. However, the T111 siding was in pretty good shape. And so when funding is short, you can go back and isolate the areas that really need to be taken care of, and then go back over systems if they're doing fine. Really, the one thing I want to drive home on these photos is destructive testing. Get in and figure out what you have. You should, if you're working with a contractor, set up allowances for what that is going to be on the project, because you can't know. You can't open up every single wall. But you need to really get in during the design and pre-construction and open up some stuff. Figure out how far spread it is. You can have a responsible allowance. If you set up an allowance that's too small, that's really painful later. But if you set up it too large, it could really hurt the budget, and you don't get to invest in some stuff you may have wanted. So really, the due diligence here is what I want to strike home. Is these guys are only able to do so much in their CNA, right? They're going to identify, hey, this looks like it's suspect. This looks like it's at the end of its life. They're not going to get into it and start tearing it open. That's when you really need to get somebody in there, a competent contractor, to get in there and look at those systems.
And I will say, at some point, just replace it. I mean, I did a site that I think there was pushing 1,500 holes that they had drilled to test the T111 siding. It probably would have been cheaper to not pay an engineer to drill all those holes and just reside it. But and that's challenging in the world that we live in now, because it's all about knowing it and getting the budgets down and not having that flexibility to say, I'm going to go hit it with a hammer and I'll replace until I can't break any more substrate, and then we'll be good, right? So yeah.
Everything in moderation, right?
That's the word.
And so here's what you need to do. It seems like common sense, but going back with your proper Wrb, going back with a good barrier that's going to have proper lapping. It's going to drive that water away from the building. That cladding is just that. It's a front line of defense. You really need a strong Wrb behind that to protect your
Do you want
buildings.
to explain what a Wrb is? For
Yeah, a
those
water
who might be listening?
resistive barrier. So
Not
it's taking your moisture away from your building. And then of course a strong, yes sir.
I'll let you finish. I actually have a question before we move on.
Sure. And then going back with a good long-term cladding system. So here you can see on the right-hand side is what then that ultimately looks like. But yes, question?
Yes, so it's related to more of a roof assembly. I'm not familiar with the details for solar panel attachments to the roof. But I don't know if you have any recommendations or considerations for how those attachments on the roof that will allow for penetration for many penetration.
So to repeat the question, what I understand you're saying is when you have a lot of systems that need to be put on the roof, how do you address that? How do you maintain roof integrity when you have to put a PV system up or otherwise? Well, I would say that one, you need to have somebody that's competent up there, and you need to not just trust the PV guy to go up there, but also have your roofer integrated into that work. There are systems and there are products that are designed for that specifically, boots, attachments, things of that nature. Really the best line of defense is to utilize those items. It's all about the lapping. Water is going to flow downhill most of the time. And it's about getting the proper things in there. It sounds old school and easy, but don't cut corners, right? Make sure that if you have a PV installer going in there, you have a roofer going back and making sure that everything's done properly is what I'd recommend.
And one thing I do know is that in that industry, they're working on trying to make those things more lightweight and less points on the roofs. And they even have some for flat roofs that are more like a ballast sitting on it. So people are mindful that, you don't want to add a bunch of holes up there too. And yeah, it's just about having people on your team that are well-versed in how to do it. One thing I will say is that a lot of those systems that I'm seeing that were done in the 90s, again, they've created a lot of penetrations because you have to get all that conduit up to the roof. And so they are, again, running up through the siding and through the soffits. And so it would be nice to have maybe a pre-construction meeting with your solar company and your contractor and your roofer, and kind of try and come up with a plan that's going to be the cause the least penetrations, and just the best route for those systems, and not just let it be a design build thing where they put it wherever they want, would be my recommendation. Yeah.
Just a suggestion, if you're able to have a metal roof, then they can attach the solar panels by just clamping to CDC and then avoid all of them.
Yes, that's a great point. So for those of you that aren't here, what was recommended was if you're able to do a metal roof instead, then that solar panel system can be basically attached to the standing seams, and then you can avoid the penetrations. Yeah, it's got to be standing seam. Another question?
So the question was wind uplift, and does that also, are the clips designed to account for the uplift force? And I'm seeing a head nod, and I've experienced the same thing as well. We do that routinely on some commercial projects too. Recently did it in Salem where we had a large PV installation, and it was all metal roof, and it's all calculated, engineered, and it takes care of the uplift, yes. Metal roofs are nice.
Mm-hmm.
So the comment was the standing seam metal roof doesn't rely on neoprene washed fasteners, which is, yes, again, it seems crazy to put down that roof and then penetrate it with a bunch of fasteners. So the standing seam is nice when you can afford it.
I will caution you on your metal roofs.
Yeah.
As an inspector, I've seen an awful lot of them leak. If you are going to do a metal roof on a project, you want to design it with that in mind. If you're going to retrofit a metal roof onto it, you need to cut all the plumbing vents off and relocate those after the metal's been installed, so you can get the boots in the right places. Your valleys and dormers and things are real hard to flash out properly. There's a lot of details that may render a property not viable with a metal roof because of the difficulty of flashing metal and getting it laid up like an architectural roof would be. You get a lot more options to get a couple layers in there. You're doing it with one layer on the metal roof. I own two that have leaked since the day they were installed. Salem Housing pulled metal roofs off of their projects because they were having too much problems with it. So just a word of caution, they need to be designed really well.
Pros and cons to every type of system, right?
Indeed.
Balconies. Durability is key. All right. Anyone want to take a shot at this one? Seems head nod, fairly straightforward. So basically, our posts, when they are directly to the concrete, I guess I'm happy that they're not buried in dirt, because they'll start to deteriorate faster, so that at least they have one layer of protection. But over time, even if it's pressure treated, it is going to start to deteriorate. One of the things we've also noticed is you can start to hit them up higher and they're actually deteriorating on the inside, so they're fairly hollow. So it might actually be worse off than you even realize just at first glance. So if you start to see the situation on your properties, I would recommend just monitoring it ongoing, making sure everything above doesn't look like it's starting to settle on you or Bo. And if you need to, get a professional on site to take a look. But there are some architectural solutions that you can add on the front end. So this post on the left is actually from the same era of construction as the two previous photos. So this one, what they do is they actually have an attachment that is lifting it up off of the concrete. So it's not sitting in the water, it's sitting in a bracket. And then it has some siding that is an extra layer of protection around it. The drawing on the right is an architectural detail that's essentially showing a section through. It's the same type of thing where we're lifting it up off the ground, having a gap between the bottom of the post and the concrete, and then wrapping it in siding, directing water out. It is going to cost a little bit more on the front end, but then it's going to last longer. So especially if you can at least lift it up off of the concrete, that would be step one. And then if you can wrap it as well.
Here's also a photo from a project we did together in Oregon City. Here, what I'm trying to illuminate is in the vintage of these properties, 70s and 80s and 60s, you saw a lot of these metal pan concrete stairs and also precast stairs. And they look really, really durable. They look great, but if you really start getting close to them, you'll see there's usually a lot of degradation of materials. The steel starts to rust out. And so we'd advocate that you really look closely at these. From afar away, they look like they're very sturdy and wonderful things. You really get close, and it's very painful when you're doing an occupied rehab to be touching these, as it can be touchy. It's a long lead. You don't want to have people out of their homes for too long, but I would encourage everybody to really look at these entries and think about what you need to do to make sure you're set up for success. On the right-hand side, the other thing, I want people to pay attention to the heads, to the noses of the stairs. Looking down, it is very hard to see where that stair is starting and stopping. There's a lot of people that have mobility issues, that have eyesight issues, that are impacted elderly in a lot of the homes we build. Be really cognizant of how those stairs are impacting their lives. So look at that nosing on that stair. And I was, yes.
Easiest to maintain, don't need as much work 30, 40 years later. So when it comes to designing a new building, that's kind of what we're starting to think about. No decks and stairs into the building, or at least even a doorway to cover them so that they're not outside.
I absolutely agree. Yes.
Do you want to say her comment for?
Oh, yes, I do. The comment was that over time it's been noticed that stairways that are integrated into the inside of a structure tend to show less wear, hold up better over time, and just less impacts to them. So easier to maintain, better. And I agree. What is the solution for this? Well, financially, you're probably not going to frame in this building and build an interior stair. But it is to come and rehab it, to pull it out, put new steel stairs in, put new stair system in, but just to rehab it.
And stairs is one of the areas where you want to be really careful in your maintenance and repair program. The stairs are rated much different than residential stairs. And so we see a lot of maintenance getting done on them that's done to a residential standard, not to a commercial standard of the stairs that we're dealing with, and the fire ratings and different things of that nature. So it's a really important area to hire a quality contractor to do the repair and think about it more holistically. And in your planning, cover them.
Yeah, the big hat that I was talking about earlier. The ones that have a cover over them fare better over time.
Yes.
Okay. Do you have a building where the stairs are all facing the same? Oh, so the question is, she has a property that has some existing stairs, and she's trying to figure out if she should replace them, and getting conflicting information about the estimated useful life on them. And you said they're pressure treated treads. So what I would say is building orientation is also going to have a pretty big impact. So I don't know if the site, if there's multiple stairs, and if, so the ones that are facing south and west and more weather exposed are probably going to have a shorter lifespan, where ones that are more protected will last longer. It's funny in architecture school, because, you know, we learn about all the different orientations and how they affect the buildings in various ways, but really going out as an inspector and seeing the same design in different orientations really impacts how well that side's going to fare. And then also, you know, looking at the wind, and so just all the different site factors, trees, shading, everything. So without actually being on site, I would say maybe focus your funds on the ones that have the heaviest weather exposure, and see if you can't maintain the other ones, if you don't have an ability to replace all of them. You're welcome. Ventilation, know your system. All right. Can anyone see what's happening in this photo? Some organic growth or moisture. Yeah, so we see this obviously most evident in restrooms, especially if there are showers or bathtubs, the areas of units that have the most moisture. So if you go to the next slide, one of my biggest things that I like to advocate for is replacing your exhaust fans if they're not removing enough moisture, you know, from day one, because they're undersized for design. Have a mechanical engineer go in and look and see what they should be upgraded to, or if there's a different way to pull it out through the roof. Also, not relying on systems that rely on the operators of the space or the users of the space to turn them on, but being tied to a light switch or an occupancy sensor. I think property managers should be going in and having, you know, an ongoing plan of planning on replacing these a little bit at a time every year, because if you can just not allow the excess moisture in the first place, then you're gonna resolve a lot of the problems that tend to then become more robust, and you may not even you know that they're occurring if it's not being reported. I personally had this experience as a user in my younger years, where, you know, I'm an architecture student and my exhaust fan's not working, and I'm like, I'm gonna keep using it even though, you know, it's really loud and it was annoying the other tenants in the building, and my landlord kept coming and gluing it back together, and I'm like, you guys, this thing is not working, we need a new one. And I single-handedly got the whole complex to get new exhaust fans. Yeah, there's a question.
House ventilation that run a little bit all of the time. Are you seeing that in the industry? Or that's going to be a requirement for construction?
I am not familiar with that one, so yeah, I'll have to go look into that and see how quickly that's coming. Yeah. Okay. All right. So yeah.
We're running into it on new construction, and oftentimes you can look to your bathrooms to be running all on, and that is an opportunity to have your venting. So you can have your bathroom vent do some of that. Depends on the size of the space, and et cetera, et cetera. But we've been seeing that, yes.
And it definitely works. I've done numerous properties in several states that they've done continuous spot ventilation. It's a good system as long as it doesn't get out of control. It has to be engineered. It has to be balanced, or you can really cause some problems. I mean, you know, but a commercial ventilator on the roof, spinning 6 to 8 units all at once is with a pressure regulator in the actual unit for each bathroom. They use a little nanotube thing that adjusts the ventilation automatically to keep it right. Is a godsend, both all the way through the system. The tenants can't mess with it and thwart it. The maintenance guy has one fan per 8 people to take care of, and it's easy to clean, and it's just really cost effective. It's a good thing.
Yes.
I guess I was just wondering, we replaced the two with the more switch, and they're they're not. So I don't know if you have enough recommendations of the program for a little bit of ventilation.
Yeah, so the question was, they have a property that has many, many vents and has a moisture sensor on it, and it's not very cost effective. I would say the continuous venting is probably the easiest, most cost effective. And then I've had projects where we've integrated, it's always on, so it's always venting. And then when they go in, they can up it to what they'd like, and then also integrated occupancy sensors. So taking it away from the end users, taking things away from individuals to create the building science, right? Having the building science work on its own and being passive is ideal in my experience.
So if it's more cost effective, is that if it's part of a rehab though? If she's trying to just update 1 or 2 at a time?
Yeah.
If they're all going into the attic, it's pretty easy.
Yeah.
Okay.
Yeah, I would say that provided that they're ducted correctly, and we're going to get into that. It should be relatively easy. It should not be a deal killer, but I don't know the finances you're working with.
I mean, if you're continuously venting though, you're energy efficient, right? So you're
Mm-hmm.
there are these Wrb type systems installed. There's also through the wall ventilation as well. It seems like if it's always on.
So it's very low. It's a low flow. So yeah, so the always on is a low flow. It's getting your minimum ventilation through the space. So you're just always getting that continuous.
And you're absolutely right. And I've talked to a lot of maintenance guys about it in the early days when we had timers and different things like that. You may even need to, every move in, be adjusting that flow rate by the number of people that are in that unit, and various things like that. So you got to do it right to keep that energy cost down, and there's got to be there's a significant health improvement in that picture as well for the tenant, to get that air moving and going. So we've all seen those units that can't imagine how they live.
Trickle vents, or what are you talking about? Mm-hmm. Mm-hmm. Yeah, I'm glad you brought that up. So, looking at this picture, I think this is your slide, right?
Yeah, I think so. Yeah, so this was another one that we wanted to bring up, in that we've walked around properties and seen situations where, so it's, I guess the photo, it's a little bit hard to see, but basically there's ventilation coming in through the frame, kind of at the top of the window. And so that's where it's trying to get some of its makeup air and airflow. And if a property has had window failures and they've only replaced a couple here or there, we've noticed that they don't maintain those vents, and then that starts to have impacts to the units, where we start to see more moisture in them. And so just one of those things that if you are doing repairs for a window that's broken, making sure that you understand that some of them have this, and it's part of a greater system. And so if you're not making changes to how you get air into that unit, you need to maintain those, or else make a more, holistic change to that unit. So we're getting that airflow.
And just put bluntly, in the past, when we had envelopes that didn't have a weather-tight barrier on them, we assumed that we got the fresh air we needed from wherever it might have come, whether that was pulling radon into your unit or something else into your unit or what. And now you're going to see they know where it comes in, and they're moving it through that unit, engineered out, and it's got to be balanced and managed, because we build them tight now. They do a good job. It's, and that's where we get the durability. We can no longer accept it to be unknowingly surviving. And we have to kind of plan this building, because as we added energy efficiency to that building, we greatly affected its durability. And so we're starting to come back now to where we're getting our durability back in a lot of places, and keeping our energy efficiency up, and even making it better now with the exterior insulation, giving them a really nice air barrier and whatnot. So all this stuff has to be planned and then maintained long term, or you can have some horrific problems occur when they don't maintain those systems, or they don't understand the penetrations.
Yeah, so the comment was that what they've seen is that in the bedrooms, people are keeping their windows closed and they're not getting airflow in those spaces, and they have window coverings up or blinds, and so the bedrooms need increased ventilation. And yeah, to kind of pick up on what Dan was saying, the energy code keeps moving us towards tighter and tighter envelopes, higher R values, which is good from a user standpoint of keeping the spaces more cost effective. You can keep the temperature control better, but we have a continuous air barrier that's getting tighter, and so ventilation will become key as we move forward in these newer buildings, and making sure that we're maintaining that ventilation and not relying on cracks and kind of the openness of the structure that we had in the past.
All right, more of the same. I would ask you guys if you can see the problem, but it's pretty self-evident. Again, it's you're having your units breathe, but you need to have your whole building breathe. And so really now going up into the attics and the crawl spaces, it can manifest itself not just in the degradation of your roof sheathing, but also moisture down. It'll maintain moisture in that insulation layer and really affect the livability and frankly the health of the end users. So the important thing here,
I have a question.
Yeah.
That's a really good thing to notice relative to the attic, whether you're actually vented properly. A lot of times it's bathroom venting into the attic. So it's just putting all this moisture in there.
Right, you remove it from the bathroom and you put it into the attic, and it makes no sense. Agreed.
Just comes right back into the unit.
Exactly. Well, and I think that's the important thing we're trying to, so you think moisture in your attic, it's bad for your roof, it's bad for your sheathing, but the photo on the left-hand side is it's affecting the whole system, right? So you're gonna see that play out in your ceilings, and it's gonna integrate into the space, and it's bad for the health. So the important thing here is getting the proper flow. You wanna have that intake air low, leave high. If you can, ridge vents is what I prefer. They tend to do the best. You have that air going out the highest point. They're also less prone to leakage, as you have one vent running down the entire ridge as opposed to many different vents throughout. But both are great. The important thing also I wanted to show in the picture on the right is baffles. So as we get more and more insulation, it's very easy for your soffit vents to be obstructed. And if you don't have air coming in, you don't have air going out. You got to let that system breathe. Then, As we talked about, how to properly vent, you often see where people will just take the vent and they'll toss it up into a can, or even worse, you'll see it where it just dies into the attic space as you described before. So really making sure those connections are done properly. You don't want to just take that moist air and dump it into your attic and it's going to sit there forever. So really, this comes down to having it properly designed, but then also properly integrated into the system, making sure that you're checking to make sure that's done well. Have quality contractors in place doing these systems.
Mechanically fastened through the roof system. Nothing else.
All right, air conditioning, consider cooling. So we see a lot of the through window AC units. I guess, do you guys have any ideas of what I don't like about these? There's a couple different things that I have concerns. Yeah. Correct. Yeah, those are two of them. So basically, the one on the left, that basically with the piece holding it up, there are penetrations going in and creating water paths through. The one on the right, it is kind of questionable how it's even attached in the first place and looks like it might be a safety hazard for people below. Another thing that's come up recently is when these are located in a bedroom, your window is supposed to be your second point of egress. And so people trying to get out when you have something that's fixed in there is a concern. So what are some alternatives as, you know, here in the Pacific Northwest, things start to, you know, we start to see hotter temperatures, especially in the southern properties. You know, I'll see these almost throughout the entire complex. So next slide.
Yeah, so solutions on a rehab, we like mini splits. You're limiting the amount of penetrations. You can see a photo on the left, not attached to the building, it's on a pad. But you just have one connection, that line set that goes into the head unit, and you can do multiple head units if you want to put in some cooling into a bedroom as well as a living space. Minimize the amount of penetrations to the envelope. And also then I wanted to demonstrate on the right-hand side, just you may end up with a project that it seems like you can't get cooling into it. And I would say really scratch hard and think of ways to get it integrated. The structure you see in the middle was a cast concrete structure built in the 40s, early 40s, and that thing was designed to an inch of its life. So the parameters we had is we couldn't put any new penetrations into the building. Distances were too great to do mini splits on the roof. So how did we get a PCAC in there? Well, we worked with QED, our envelope consultant, and our window manufacturer to figure out a way to actually integrate a PT into the window system. A lot of brain damage, a lot of long nights scratching our head, a lot of thinking with our owner's rep on ways to do it and not get calls back in the future. But I would say ingenuity. Things can look hard, but cooling really, really makes the space better for the end user. And as we talk about ventilation moisture, they also remove moisture. So they're very beneficial to the space. So the main thing here is just always be thinking of ways to get it done, not reasons you can't get it done.
And then the next slide, if you're not part of a full rehab and you're trying to make some improvements, the one on the left is the freestanding type units where there's just the piece inserted into the window. I think those are a better solution. The other thing that I came across is Energy Trust of Oregon has a program where you can create a cooling space that's more of a community location. And so at least having one spot on your property where people could go if they need access to cooling. And so I would encourage people to, you know, look for other funding sources and incentives through Energy Trust of Oregon. I believe that Ellen Shepard is here as well, so you could try and connect with her at some point in the next couple days. I'm not as robust in all, or I don't know about all of the details of, you know, those items, but I know they're out there, and so just wanted to kind of highlight that as something for people to look into.
All right, amenities and understanding needs. So who can tell me what's going on in this photo? Yes. Sure. And what do we think has caused this? Is it rodents? Is it a pipe leak? Is it water? Is it is it not great drainage? No, it's kids, right? So knowing your community and building spaces for those people to have fun. That it seems like it's an afterthought. Oh, the budget doesn't support it. Well, it does impact your property. Kids will find a way. They're going to have fun, and if it's making mud pits and dirt pits and kickball and anywhere, they're going to find a way, and it's going to end up impacting your property and investment. So always be looking to create spaces for your end users to better their lives and better their property. Any comments on this?
Oh, it's called management.
I would also go back to the comments about the early on, the first slides we did was landscaping. We talked about there's a lot of hesitation every time we talk about putting rocks around buildings and borders. I always get the comment of kids throwing rocks. This goes a long way to keeping kids from not throwing rocks. Keep them busy, keep them where you want them, not finding entertainment themselves. The kids get bored. They find entertainment.
For the older kids, I also see a lot of temporary basketball hoops. And so if there's an opportunity to provide, a permanent basketball hoop, I think that would go a long way for the older kids, in addition to the playground for more of the younger ones.
Question?
Yeah, that is a good point. So I do know that as the play structure gets higher, there's certain triggers for, how much thickness you need for the padding, and then also the fall protection. So maybe if you have a more compact space, focus on like rock climbing walls or things that, aren't, there's some of the short ones you see at the elementary schools that maybe they can reduce what your fall services area is. But yeah, there are going to be, some limiting factors on certain sites. Swings are probably not going to be the best option and don't show up very, very often anymore, so avoid those.
Do you have any tips on playground service, materials, maintenance?
The Holy Grail.
Well, any preferences or times that you recommend that last the longest and where the best?
Do you have an opinion on that one?
Boy, we're definitely going to see a lot of engineered surfaces now. Definitely much better than the bark and pea gravel and sand that we came from. And I probably would say your best bet is to go with something that's maintainable, something tiles you can pull out or put in. To deal with the wear points as those occur. Your maintenance guy can do that, and the stuff is changing so much. Try and get something that may be there in the future. I mean, it's
I like the rubber tiles
Yes.
because it's more accessible. So kids that might be in a wheelchair, have mobility issues, it's easier for them to move around than the wood chips. This one was actually a rubber chips. And it does seem like all of those systems, have similar estimated useful lives. And so you kind of got to pick the best one for that scenario. But yeah, I like the rubber tiles for the reasons that they've said.
Completely agree. The rubber tiles, again, you can go to the points in which you have the most wear. You saw the earlier engineered surfaces where they were poured in place and they were multi-layered. You get the wear points, and then you see where it's very expensive to replace the whole thing, but you only have the wear points. And then what do? And then people fill that in with chips or other things, and that exacerbates the situation. So the tiles give you that flexibility to replace as necessary.
The other thing is that they're going to be there over time, where with the chips, we see a lot of times, you know, the kids move them around and you have low spots, so you don't have the actual thickness that you're supposed to. And they're not getting replenished, you know, to as high as they need to be for one reason or another. So at least with those rubber tiles, you know, it's going to be there. It's designed from day one. Mm.
They change, you know, how they connect over time, and if you don't have the same brand, same kind, then
Think carpet tile. So the comment was extra stock. Absolutely. Just like when you get carpet tiles, you get extra stock because, of course, this line of whatever is never going to be discontinued. And 2 years later, you go to get it and they tell you it's been discontinued. Attic stock, attic stock, attic stock. Yes.
It was also mentioned that their tiles have lasted 30 years. So they are a durable system.
Those were good tiles.
Probably can't get them now.
All right, so we're not really going to get into the nitty gritty of the codes and laws, but I just wanted to highlight following the correct standard. So if you want to go to the next slide, anybody have any ideas on this one? Yeah, protruding objects. And then on the right is a stair. And so basically, one of the questions is, you know, why do I have to get a transition plan every 3 years? You know, nothing on my property has really changed, but you could do something where you have a light fixture and the maintenance guy, you know, is trying to make it look nicer. And so they pick one. And then before, your light fixture was actually under the 4 inches required, and now it's a protruding object, and just nobody had an awareness that that was even an issue. There's, you know, a lot of standards that you got to be mindful of. The other one is stairs. So if you go to the next slide, there are codes for the state of Oregon that have certain requirements. So for a stair railing height, you have a range. When you look at UFIS, it's very specific about where it wants that railing height to be. So the last thing we want to do is show up to a property and see one where they've just replaced everything, they're super excited about it, and then the railing height doesn't meet the UFIS standard that it's supposed to. So really make sure that you understand your funding source and which standards you're supposed to be following, because, you know, when we start having the federal codes impacted, then we got to be picking the one that's the most restrictive and just really trying to make sure that we're meeting all the standards. So you might even want to just have a conversation with your architect and make sure that they understand if there's federal funding, because as architects, there's a lot of things that we're trying to manage and codes that are changing. And so yeah, I just wanted to highlight that.
It's not good to be an award-winning property and not have your handrails right.
So we have made it to the end. I think we have, you know, just a few minutes left. If there's any final questions, I know people were good about asking questions throughout, so hopefully we've addressed most of them. But are there any others that kind of waited for the end?
Is there one that's the most strict? I mean, typically when we're looking at projects, it's easier for us just to take like the most, you know, difficult,
Yeah.
complicated, and just make that the standard in doing all of our projects, and then make them kind of standard specs that way for every single project. Is there something that's
The question is there one code that or law or that's the most strict, and that you could just use that one? And unfortunately, I don't think that across the board that exists, because one of the things is, like in a restroom, they have very specific locations of where they want the bars and UFIS, but then on the Oregon code, there's also a vertical bar that's been added. Then for stairs, you know, you have it's strict in that they want the railing height at 34 inches, but in the Oregon code, you have a range. So I don't think that there's just one solution that fits all. And I have talked to rural development architects, and it sounds like UFIS is still here to stay for a while. So it's just something we need to be mindful of.
And probably what you kind of need to understand a little bit is that UFAS is really doing the housing side of stuff, where the Architectural Barriers Act is doing the public courthouses and that sort of stuff. And so there's some give and take in each of those that kind of reflects that. And so UFAS has some stuff in it for the housing side that's different, and it doesn't have the commercial space stuff that well. And so that's why I think they've been talking for a lot of years about trying to change and not use UFAS anymore and whatnot. And it generally, the discussion boils around to, but it's got this for multifamily and that, and it's helpful. And so that's kind of why I think it's going to stay.
I think we have time for one more. Any other questions? I think that takes us to the last slide then.
All right. Well, thank you everyone for joining us. I really appreciate the engagement and the good questions, and hope you guys, learned something new today, and good luck with your properties.
Thank you.